Good morning, everyone. Welcome to our lecture about text normalization under the subject DS411 Predictive Analytics. This will be our topics for today. We'll start with a very basic introduction about text normalization and the preliminaries before we can go to coding. Then we'll discuss how can we do text cleaning, such as removing punctuation and removing repeating characters. We will also discuss how to deal with contractions and also the different stop words in English language. We'll also do check spelling, and the last topic will be about stemming and lemmatization. Okay, just a short review, no, and the basic term about text normalization. Of course, what we'll be dealing today, we will be having an example of a corpus. So when we say a corpus, we refer to the collection of text documents such as news articles, tweets, and reviews. And also don't forget our previous topic about the concept of tokenization. So we will also be dealing about tokens, which we mean that those are the basic meaningful unit of a sentence or a document. Maybe later we can discuss about n-grams, wherein we refer n-grams to a combination of n words or the number of words or characters together. So let's say, for example, given a sentence. Now, when we talk about tokenization, we could either identify a token, which is equivalent to word. So when we say unigrams, wherein n is equals to 1, we refer to an individual word such as the I, the love, the my, and the phone. When we talk about bigrams, wherein n is equals to 2, so we mean a combination of two words such as I love my, and my phone. And of course, the last is what we call the trigrams, wherein n is equals to 3. So those are a combination of three words. So you have I love my phone. So those are some of the basic terms that we'll be using for our lecture today. Of course, just a review about tokenization. It is the process of splitting a text object into smaller units known as tokens. So today we'll be telling about how to normalize the different um, today we'll be discussing about the different normalization techniques, so which we refer to the process of converting a token into its base form. Part of the normalization includes tokenization. There's also this cleaning of text. Yeah, there's also the case conversion, which is very easy with a given function. We'll also correct spellings, remove stop words, and we'll discuss stemming and lemmatization. Everything under the processing of text, or what we call tokenization, belongs to what we call the natural language processing. Now we'll be using the Python Jupyter notebook. Of course, we'll be using the different libraries such as the NLTK, the regex library, and also the string library. So we have this an example of the corpus, which is composed of three sentences. So notice that the spelling of race is wrong. We also have different punctuation, the apostrophe, and then the exclamation point. We also have other punctuation such as the parenthesis, and then the asterisk. So yeah, this is a very basic example of a corpus. Of course, we are going to perform tokenization, and that is we will tokenize our corpus into a word. So we have to deal with words. When we say text cleaning in the content of textual data, with your previous example, when you scrap the web. Usually, your document contains different HTML tags and other punctuations. It's actually a very dirty data, and then those tags are not necessary for us, even as humans, to understand. Also, when we try to clean a document such as PDF, it may contain numbers, extra spaces, and also punctuations. Other things, when we talk about informal, such as the different reviews, others may type it with the wrong spelling, and the others may type it, if really they are really emotional, they are to type it with repeated letters. Of course, others too prefer to shorten or combine the different words. Okay, so those are actually, these are what we call the dirty data. Now, when we try to understand text, so usually we refer to a formal type of written text, so that we can establish our vocabulary. We have that formal type of written text. Now, let's start the ball rolling. So, when we say punctuations, so you have this different punctuations which can be found in your text document. So we have this function, you pass the string, and then you define first your punctuation. So this is a string, another way of a string constant value, and then you try to remove the punctuation if character is not in punctuations one at a time. So you have to add those character into your no punctuation um, string variable. And then what will happen if you've added a space? So what happens here is that your corpus, your text is one whole long word. So this is the function in removing punctuations. Yeah, so let's say for example, we wanted to remove this values. We wanted to remove the dollar sign, the backslash, and the different punctuation. So since my corpus is a list of statement, so we try to iterate with our um, list, my corpus. So you call the remove punctuation, then you pass each statement. Then of course you have a token list. It's a statement list where you try to tokenize those um, different the remove um, the different string wherein you remove the punctuation. So the output here, since we try to tokenize the output, actually the remove punctuation here is one statement not being tokenized, but the punctuation is being removed. So what happens here, since we call the tokenize function, so try to look at wasn't, the apostrophe is being removed, and then also the odd here supposed to be there's dollar 144 that's being removed, so you also have here the odd. So that's how you remove the punctuation. Now, there is a tendency that we wanted to repeat the different characters. I think this is up to 3 level of repeating characters. Of course, don't forget to call in the word net under corpus. No? So we try to call the library and match the substitution between those repeated characters. So it tries to call the senset function with the word and then return old word. So you have the new word, so repeat pattern that substitute. So you have the match substitution with the old word. So it's actually up to three layers of conversion of repeated letters. So we have here a sample output. If you have sentence, my school is really amazing. So you have a repeated characters. So if we don't omit the repeated characters, so this is the tokenized text. And then when you try to call the remove repeated characters functions, so I don't know what happens to the spelling of really here, but one L. Okay, so that's the removal of repeated characters.